Hey everyone, this is Seth, and in this video I'm going to show you how to use the order of operations to solve convoluted statistics formulas. This is the second video in my series on prepping for your first stats class in the social sciences. Last time I talked about how arithmetic, just basic addition, subtraction, multiplication, and division, is really the core that you need for your first stats class, especially at the undergrad level. But what's tricky is the way that we combine all of these operations into something like this. And if you haven't seen this particular formula before, it might look kind of scary. Ultimately, though, this is just going to break down into subtraction, multiplication, addition, division. So you can use the order of operations that you learned in grade school to take something, no matter how convoluted and scary it might look, and break it down into simpler steps. Here's the version of the order of operations that I grew up with. In different countries, they might use different terms like bracket, for example. And I actually should have used a number list here because these do go in order. So first, we do anything inside the parentheses. Then we do anything relating to exponents. Then we do anything with multiplication and division. In one sense, those are kind of the same thing. So they could go on the same line. You could do division before multiplication, doesn't really matter. And same for addition and subtraction. They're really two different forms of the same kind of operation. So, but if you don't want to think about that, you could just think this is the order I do them in. One point I want to make really quick is this is a convention. This is not a law of nature. So like if we had 2 plus 3 times 5, using this approach, which we all use, we would say multiplication. The m comes before the a. So 3 times 5 is 15, then add 2 to get 17. But what if we lived in a society that said, no, we would rather go left to right? That's not wrong, but the solution here would be 2 plus 3 is 5 times 5 is 25. So you get a different result. This is not the way that you're going to do it probably, but it's not right or wrong. The PEMDAS is the way we all agree to do it. Because we just need to agree on something. If we used like a different convention, like the left to right thing, we'd have to rewrite all of our formulas, okay, to write them to be in alignment with that. So this isn't a law of nature. This is just how we all agree to do it. Okay, enough on that. So let's walk through an example. This is the formula for the variance. Specifically, this is if you have sample data and you're estimating what this would be in the population. If you haven't taken stats yet, though, that's not going to make any sense. So don't worry about that. The key point is we're going to use PEMDAS to break this down piece by piece. So the first thing we need to deal with is parentheses. What I see in parentheses is x minus the mean of x. That's subtraction, okay? Remember, in statistics, when you see a variable like x, that refers to a column of data. In this case, we have the numbers 1, 2, 3, 4, 5. So when we say take x and subtract the mean of x, that means subtract the mean. Well, so the mean of 1, 2, 3, 4, 5 is 3. So we're saying subtract 3 from each of those values. 1 minus 3 is negative 2, 2 minus 3 is negative 1, etc. And we end up with a set of deviation scores. These are deviations from the mean. Okay, so that's our first step. Here's the key thing to understand. In this case, there's only one operation to do inside the parentheses, which is subtraction. But when you see parentheses, that means do everything, do all of these in order, PEMDAS, do all of those for whatever's inside the parentheses. So it's sort of like this hierarchical thing. If there were exponents inside of these parentheses, we'd have to do that before we did the subtraction. The reason, not this exponent, that one's outside the parentheses. But if there were parentheses inside parentheses, we'd have to do whatever's inside those first, the innermost parentheses, okay? So that's what the parentheses mean. It's a way of saying this is what you do first. Okay, so we've done everything that's inside the parentheses. Now let's go outside. Next in our list is exponents. So here we're squaring what's in the parentheses. So squaring those deviations. Squaring something just means multiplying it times itself. Now the trap here would be to think, okay, do we go right to division? After all, in our order, after exponents, we have multiplication and division. So do we now divide the numerator by the denominator? And the answer is no, we don't, because that would actually be violating the order of operations. So this is a little bit tricky, but what you need to do is imagine that when you have a fraction like this, imagine that there are invisible parentheses around the numerator and around the denominator. So what that means is we're going to have to deal with everything in the numerator separately, go through PEMDAS in the numerator, then go through everything in PEMDAS in the denominator. And only after we've done that can we proceed, because this is, well, that's the rule. The first thing is the P, the parentheses. So whatever's in the parentheses first, okay? Here's me saying the exact same thing that I just said. Okay, so what is actually next? Well, in the numerator, we've subtracted inside the parentheses, and we've also done our exponents. So there's no multiplication or division up top, which means we're now to addition or summation. Remember, this capital sigma that looks like a big Greek E, that means add it all up. So we add up all of those squared deviations. Down low, all I see is subtraction. So subtract 1 from the sample size. So that's the number of scores in this column. So here it'd be 5 minus 1. Now, only here, once we've sorted out the numerator and denominator separately, are we ready to divide. And the final result is the variance. I would argue it's actually not best to think of this formula as a complex series of steps. If you need to solve it manually, the order of operations is your guide to doing that. But I would argue, and this will be really more the focus of the next video, but I'd argue it's more important to understand the core message of the formula, like how you would explain it in a sentence. You'll sometimes see computational formulas like this. We call them computational because they are faster to compute manually, but they're going to make less sense intuitively than a definitional formula will. So here we have a definitional formula, which means by definitional, it means it may be less efficient, but you could explain what the concept is by walking through these operations. And with modern computing, you don't really need to be able to do this by hand, I would argue. So I think computational formulas don't really have much place in learning. Other people will disagree, but I don't care. This is my video. So let's go back and think. When you add up something and then divide by some function of the number of parts, that's called an average. Specifically, that's the arithmetic mean. Add up the parts, divide by the number of them, that's the arithmetic mean. So in this case, we're looking at some kind of average. The variance is a type of average. Specifically, the variance is the average squared deviation from the mean. So because this is a definitional formula, that means we could explain it in a way that starts to make intuitive sense. Like we could say, on average, how far away is a given score from the mean of the distribution expressed in squared units? Now, why that would be useful, that's not going to make sense until you take the stats class. But this is the level of understanding you want to get to with any formula. I would say be extremely cautious of accepting or even using any formula until it makes good intuitive sense to you, even visual sense to you. Try to grasp it in a way that you could explain to a layperson who has never taken a stats class before. Okay, so that's it on order of operations. In the next video, I'm going to show you how to use substitution to turn hideous monstrosities like this into cute little kittens like this. Okay, that's it for today. If you have questions, thoughts, comments, or concerns, don't hesitate to reach out to me. See you later.